All right, in this example, we're plotting these 3 points on the Cartesian plane that's shown here, and then we want to show that they form a right triangle. So let's go ahead and use the -2, 7 first. So we'll go 2 to the left and then up 7. 1, 2, 3, 4, 5, 6, 7. So that's about right here. And that's point A. And again, point A is -2, 7. Let's do point B as well. So it's 12 over and 5 up. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over and 5 up. 1, 2, 3, 4, 5. So about there, let's say. So it's 12, 5, and that's point B. And then last we have to plot point C. C is 10 over, so it's just 2 over from B and then down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe that's 9 there. And that's 10, -9. All right, so it's just a freehand grid, right? A freehand Cartesian plane. So it's not going to be perfect. But if we connect the dots here, or the points here, we'll certainly get a triangle. And the question is it a right triangle or not? Well, the way I have it drawn here, it looks like it could be a right triangle, but of course, to be able to prove that, we'd want to show that the Pythagorean theorem holds. And to do that, we need to find 3 distances. We need to find the distance between points A and B. We need to find the distance between the points A and C. And then lastly, the distance between the points B and C. All right, so remember, this would be distance between A and B. This would be the distance between B and C. And this would be the distance between A and C. So remember, according to the Pythagorean theorem, the distance between A and B squared plus the distance between B and C squared should be equal to the distance between A and C squared, right? Because this distance AC would have to be the hypotenuse of our right triangle, and the other 2 distances represent the legs of the triangle. All right, so let's go ahead and try to show that, and we'll show that by applying the distance formula and then checking to see if those distances do indeed make the Pythagorean theorem true. All right, so the distance between A and B is simply a matter of doing the 2 parentheses squared like we always do, and then we're going to subtract off, and let me go ahead and label these guys. We'll make this x, y, and we'll call 1, 1, and then x2, y2. All right, so the difference between the x's is going to be 12 minus a -2. The difference between the y's will be 5 minus 7. And that will simplify to be 12 plus 2, or 14 squared, plus -2 squared. And all of that will be under the radical. And when you simplify that, you will get the square root of 200. So that's the first distance. All right, let's look at distance AC now. All right, for the distance AC, let's label the points in C, x2, y2 now. And we'll go ahead and use our parentheses squared plus parentheses squared under the radical approach. So it'll be 10 minus a -2, and then -9 minus 7. All right, and that formula will then simplify to 10 plus 2, or 12 squared, plus -16 squared, which is the same as the square root of 400. All right, and then the final one we have to do is the distance between points B and C. So we're going to label the components of point B, x1, y1. Let's go ahead and plug those values in. So parentheses squared plus parentheses squared, and we're going to take the difference between the x's, so it'll be 10 minus 12, and then -9 minus 5 when we do the differences of the y's. So that'll simplify to the square root of -2 squared plus -14 squared. And that will give us the square root of 200 when you work out those exponents. All right, so is it true then that the distance between A and B squared plus the distance between B and C squared is equal to the distance between A and C squared? Well, the distance between A and B squared would be the square root of 200 squared plus the distance between B and C. Well, that distance again is the square root of 200, and we'd square that. And is that equal to the square root of 400 squared. Is, right? Well, it certainly is, because the square root of 200 squared is certainly equal to 200, plus the square root of 200 squared, which is again 200, should be equal to the square root of 400 squared, which of course is just 400. In other words, those radicals drop away when we square, and we end up with the relationship 200 plus 200 equals to 400, and that makes the Pythagorean theorem check out. And remember, if a squared plus b squared is equal to c squared, then it means that the sides a, b, and c form a right triangle.